Hello everyone. So today I'm going to discuss about linear regression. So linear regression is basically a supervised machine learning algorithm that learns from the labeled dataset in which the input and output both are labeled and the model trains from the labeled datasets. So while linear regression is important in machine learning, linear regression is a cornerstone of machine learning because it serves as the most fundamental and interpretable tool for predictive modeling. So as we know that linear regression comes under supervised learning algorithm. So here both the input and output are labeled and the machine or the model gets trained from the labeled datasets. So this is basically the graph of linear regression. Here is the straight line. As we know that the equation of straight line is y is equals to mx plus c. Here is the y-axis and this is the x-axis. X is independent variable and y is dependent variable. As we can see, x here is the independent variable and y depends upon the variable x, so y becomes the dependent variable. So there are basically two types of linear regression. First one is simple linear regression, one independent variable where x is the independent variable, and multiple linear regression where multiple independent variable are present, for example x1, x2 until xn. Then mathematical intuition behind linear regression. So first, model representation. How we represent the model? We represent the model in the form of a straight line. The equation is y is equals to mx plus c. Here m represents the slope, c represents the intercept, and y represents the predicted value. Then comes the error. So how can we calculate the error? The error for each data point is difference between the actual and the predicted value. Error is equals to y minus y dash. So here then cost function, to find the best line. So this line in this graph, the straight line, is also known as best fit line. So to find the best fit line, we minimize the mean squared error MSE. So y square, the error penalize the large errors more, make the functional differentiable. It makes the function more differentiable, ensure single global minimum. So what is basically the pipeline for linear regression? First we understand the problem, then we come to data collection. Here we take the data. Here we have considered the data iris that we take from Kaggle. Most relevant data from the reliable source such as CBS file databases or online data sets. So here we are in linear regression, we consider the data iris. Then we have defined the data. Then comes the data processing, which contains handling missing values, removing duplicates, converting categorical data into numbers, scaling features if required. Then comes the EDA. Then in EDA, analyze the data to understand relationship between input feature and the target variable. Here in under this section comes the graph or the output we plot from our code. Then we split the data set into two parts, train and test split. Then first is the training data is used to build the model. We train the data to build the model and we test the data to evaluate the performance. So here is the code for train and test split. Then comes the model training. Then we train the model. The model here is linear regression. Then we train the model under model.fit x train y train. Then comes the model evaluation. Here we evaluate the matrices like mean squared error and R2 square. Then R2 square score. Then comes the prediction. Then the model makes prediction for this y pred is equals to model. From model we call predict, that is x test. Here comes some advantages: easy to understand and implement, fast training and prediction, easy to interpret as here is only one equation, y is equals to mx plus c. Then comes some disadvantages: assumes linear relationship. It only assumes linear relationships, sensitive to outliers, poor performance with complex data. Linear regression basically works with simple data. So when complex data came into action, it shows poor performance and limited prediction power. The prediction power for linear regression is very low. So that's all for this video. Thank you.